Let's just jump right into it. If you're building with AI right now, we need to talk about a massive mindset shift. We're officially moving away from the era of those traditional, rigid APIs and stepping into a world where the AI actually has agency. Welcome to The Explainer. Today, we're breaking down exactly how to connect Claude to external tools using a breakthrough framework called MCP. If you want to give Claude the ability to securely interact with your real-world data, you are absolutely in the right place. To really grasp this, let's quickly define what MCP actually is. It stands for Model Context Protocol. Think of it as a specialized integration model. But here's the real game changer. Unlike a basic automation script where you dictate every single step, do A, then B, then C, MCP puts Claude right in the driver's seat. Claude autonomously evaluates the prompt and chooses which tool to call and exactly when to call it. It might decide to query your database, check a calendar, you name it, all on its own. Because Claude has this incredible agency now, our primary job as developers completely shifts. Listen closely to this part because we are no longer scripting the sequence. Our job is now to set incredibly strong boundaries and rules. So to understand this shift, we're going to look at three critical areas: scoping tool access, mastering tool descriptions, and orchestrating multiple tools. After that, we'll dive into a real-world field story to see what happens when things go a bit sideways, and we'll wrap up with the shared discipline you need to pull this all together. All right, let's kick things off with our first area, scoping tool access. This is all about risk mitigation, especially when connecting Claude to sensitive stuff like your databases. There is a stark contrast in the potential blast radius here. When you use a weak approach, like just handing an MCP server full database access, you're essentially giving the master keys to a very fast autonomous agent. The area Claude can access becomes way larger than what's actually needed. And, if a user enters a weird prompt or Claude just makes a mistake in inference, a single accidental action can have a catastrophic impact on your data. But look at the strong approach. A strong scope clearly defines exactly what tools are necessary and explicitly forbids specific actions. You aren't just saying, access the database. You're saying, grant read-only access to exactly these three tables and absolutely disable write and delete commands. By scoping it this tightly, you guarantee that even if Claude makes a mistake, the error is totally contained in a heavily padded area. It's basically the principle of least privilege, just applied directed to AI agency. Moving right along to number 2, tool description discipline. This is all about how you actually communicate a tool's purpose to the AI. Here's the thing you have to remember. Claude doesn't magically know how your internal systems work. It relies entirely on your words to know when to act. If you go with a weak approach and use a vague description, like fetch data, you're forcing Claude to guess. And when AI guesses, well, it might call the tool at the completely wrong time, or worse, ignore it entirely when it was desperately needed. A strong, disciplined definition completely eliminates that ambiguity. You have to be explicit. Detail what the tool does, the exact conditions for using it, and, maybe most importantly, when not to use it. For instance, telling Claude to use a tool only for current weather, not past weather. That level of precise framing guarantees Claude knows exactly what triggers the tool, no guesswork, just high-fidelity results. And that brings us to our third discipline, multi-tool orchestration. This tackles the chaos that inevitably happens when your integration grows and you hand Claude multiple tools at the exact same time. This is where we hit the paradox of choice. If you just throw multiple slightly overlapping tools at the AI without any priority, like an internal document search and an external web search, that's a weak approach. Claude will often randomly pick between them for similar tasks, which leads to super unpredictable behavior for the user. To build a truly robust explainer-level application, you've got to use a strong approach, which means defining priority and sequencing logic. Tell Claude exactly how to think about its toolbox. Give it rules like, always try querying the local database first, and only if that result is empty, switch over to the external API tool. By baking this sequencing logic right into your prompts, you make the AI's decision-making totally predictable. Plus, it's way cheaper since you're avoiding unnecessary external API calls. Now, to truly understand why all this theoretical discipline matters out in the real world, let's look at an actual anonymous field story from a development team. So this team connected Claude to a live project management tool via MCP, hoping it would act as an autonomous project manager. But they made a massive error right out of the gate. They opened up all permissions, create, edit, delete, and gave the tools super vague, weak descriptions. Because the AI had total freedom but terrible instructions, it turned into a disaster fast. Claude would literally delete the entirely wrong task just because it wasn't perfectly clear which tool to use or what the exact parameters meant. They basically handed a powerful AI a bulldozer, but completely forgot to put up any fences.
So how did they fix it? They had to hit the brakes and completely rethink their strategy, using the exact principles we're talking about today. First, they heavily restricted the scope. They limited Claude's access to just read and create, totally disabling the delete function at the MCP server level. Second, they rewrote their tool descriptions with extreme discipline, specifying exact usage rules and edge cases. And guess what? By applying these strong techniques, they brought their catastrophic error rate down to absolute zero. The AI was still incredibly helpful, but now it was operating safely within a highly governed environment.
Which brings us to our final point. Let's summarize everything we've learned into a core philosophy for your own projects, the shared discipline. The absolute biggest takeaway from this explainer is that a powerful MCP integration needs all three of these strategies working perfectly together. They aren't optional add-ons, they are a shared discipline. Step 1, limit the scope to contain the blast radius. Step 2, define the tool clearly so Claude knows exactly when to act. And Step 3, establish sequencing so it knows the correct order of operations. These steps perfectly complement each other. A weak integration leaves things chaotic, ambiguous, and wide open, but a strong one meticulously designs what is accessible, when it's used, and in what exact order it should be tried. So, I'll leave you with this final thought. Are you ready to give Claude the agency to choose, safely and securely? By shifting your mindset from micromanaging every script to designing robust environments with clear rules, you're going to unlock some truly incredible capabilities with MCP. If you found this useful, like the video and subscribe to the channel. Next episode, Introduction to Claude Code. Catch you then!